Alrighty, in this tutorial we're going to be following up on our original Bunnyhop that was running external, except in this case we are going to be turning it into a DLL and injecting it into our game so it's running internally. Go ahead and go File, New, Project. Under the Visual C++ option, just click Windows Desktop, Dynamic Link Library, give it a name. And we're going to want to do the same thing that we did before. Project, Properties, Unicode character set, set to multi-byte character set, get out of C/C++, precompiled headers, not using precompiled headers, and there's one more thing we need to add in the general, in the preprocessor defines, that I can't remember the name of, but I'm sure it'll come up here in a second. So over here we have our bhop internal.cpp, the one we created, and our DLL main. So we want to go ahead and just take our DLL main, highlight it, copy it all over, and put it in our bhop internal. Now we can go ahead and just get rid of our DLL main. So we're set up with this. Right, this comes with a little switch statement. The one we want is DLL process attach, so we can just get rid of thread attach and detach. Do our opening and closing braces. What we want to type is disable thread library calls for H module, create thread null LP thread start routine. Then we're just going to type whatever our actual name of our pretty much our main function that we want it to be called. So we're just going to type it as main, then do null. And as you will see, main is undefined, so we're going to go up here, just get rid of all this crap. Just do void main. And now we have our main function. So when we inject it, it's going to attach itself and it's going to run whatever is inside of main. So now we can go ahead and view our previous example here from the external. And we can go ahead and just copy our two structures. Alright, now if we follow along, well, we no longer need to get the process since we're running internally, but we do, however, need to get access to the module. So in our main, we want to use, actually we can get rid of process, duh. We're going to use val.gameModule equals dword get module handle, then the name, so client underscore panorama.dll. Now this should now hold our module. And from here, just same as before, we want to go ahead and get our local player. So we're going to just do, we already have it set up, val.localPlayer. And here's where it gets a little bit different, since we're pretty much, instead of just reading through process memory with our read and write functions, we actually pretty much have to point to the address we're trying to read from. So in this case, do what's that called? Asterisk. We're reading the address. So it's a type D word, which actually reminds me, do include windows.h. Another asterisk. So you can be pointing to it and actually getting the address. Then we're going to, let's see, it's the game module plus offsets of local player. So we're going to do val.gameModule plus offsets.lPlayer. Now we have our local player. So we're going to do our same check just like before. If val.localPlayer local player is equal to null. We're going to run a loop. While it is equal to null, and then we're going to do this exact same thing here. So now we need our main loop, while true. Now in here we want to read our flag, so val.flag is equal to, as you can see here, we read from the local player and the offsets flags, but it's a byte, so we do the exact same thing here, pretty much just for a byte. So asterisk, byte, asterisk, then our opening and closing parentheses. So we're doing val.gameModule plus offsets dot flags. Now that'll hold our flags. Now we can do our test. If get async key state vk space and val.flag and do our byte comparison. We're going to want to write to memory. So here's where we write the value to fjump or forceJump, whatever you want to call it. So from here it's essentially the same as the way you would read it, just slightly different. So you do the exact same thing, and in the case of this it's going to be a D word. So asterisk, D word asterisk. Then the same thing just as before, we get the pretty much the offsets that we want to, or the address and the offset we want to point to. In this case you can see it's game module plus forceJump just like before. val.gameModule plus offsets dot fjump. And since we're pointing pretty much to the value that this address is holding, we're going to go ahead and change it. And if you remember before, our forceJump is 6, so we're going to set it equal to 6. And that's pretty much it. If we build it, we should be good to go. Where did I forget? Line 51. Whoops. Alright, so we should be good to go. We open up our injector. See, Bunnyhop internal. Here's our DLL. Go ahead and check it and click inject. Now with any luck, once we get into game, we should have the ability to bunnyhop, which we do not. So now we can go ahead and try to figure out exactly what is wrong with it. So whenever you have issues when you're using internal stuff, you generally have to close your game. See, there's the tutorial, there's this. So let's go ahead and see exactly where the issue is. So we can go ahead and also go ahead and actually set up a console. So we're going to go ahead and print out our local player address. So just do your normal cout. And make sure we're actually getting the address. There's the thing I was talking about earlier. Project, properties, preprocessor, edit, just go to the bottom, CRT secure, no warnings. So hopefully whenever we actually select a side, it should at least be printing off the local player address properly, which it is. So now we're going to check our, make sure the flag is actually set up right. And I'm an idiot. For the flag, I was reading from the game module plus the flag's offset when I was meant to read from the local player plus a flag offset. So just change this to local player. Hopefully someone in the video actually was managing to catch that and figure it out for themselves. Alright, and now we should actually have our bunny hopping ability. Yep. So now we can just go around the map. Alright, this is just an extension. So once you've done everything, your bunny hop should be working just as normal. This is with it injected, FYI. But you see the problem is, alright, look, I have the chat open, and let's say I type something, hi, space, all. And you notice every time I hit space, it jumps. And even if let's say I'll bring up this, so this is priority, and I press spacebar again, it still jumps. So what we're going to do is just correct that. And the main way we're going to do that, it's not the best way, as you can also just see if the module is, not module, if your mouse is, I'll find the offset and remember the name, but pretty much if you're going to want to get your velocity. So if your velocity is, well, you're not moving, so 0, then we know you're either typing, you're alt-tabbed, or doing whatever. So when you press spacebar then, you do not want it to jump. Okay. So now, pretty much what we're going to be doing here. So, this is pretty much our case. So what we want to do is the velocity of the player, which is X, Y, and Z positions, which we can store in a structure that we make. And here's the offset to get the velocity, and to read the velocity, just like before, how we do flags. Where is it? Like off the local player plus the flags. We go off the local player, then we add the offset for velocity. So then we want to check if X, Y, and Z equals 0. Hang on. Wait. No, yeah, that's right. Then don't bunny hop, meaning when you press spacebar, it's not gonna, force a jump. And if it does not equal 0, meaning you're moving, then it's okay. Yeah, you're gonna jump. So as for the float values that you're gonna get from here, they do return both positive and negative, but 0 when stationary. The reason why, where is it? I say right here, get X, Y, and Z, and then check if it's we're going to pretty much be storing an integer value. The reason we're going to store it in an integer is because you'll occasionally get it to where it's like, it'll spike, one of the values will spike to negative 0.01 or something like that. And when that happens, and you're just having to be pressing spacebar, which is actually quite more often than you might think, it's, well, obviously it's going to jump because pretty much it just doesn't equal 0. It's acting as if you're moving. That's what it thinks. So if we round it to an integer, it's just going to round to the nearest value. So if it's 0.01 blah blah blah, it's going to turn into 0 if it's going from a float to an integer, because it's just pretty much rounding to the nearest value. So we're going to go ahead and go up here to our offsets and add it. So it's blah 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 110. So d word velocity equals 0x 110. Now we want to go ahead and get our velocity. Actually, let's make a new function to do that for us, and we're going to return a bool. So bool is player moving, and since it's a type boolean, not a void, it needs to return a value. So we're going to just for now, so we can compile without throwing an error, we're just going to return false, even though, well, just because if you didn't have return value here and you try to build an empty function that's supposed to return something, it'll do this. Yep. Alright, so what we want to do is go ahead and, well, since it's a boolean, we can store that in an if statement. So if is player moving, so pretty much it's going to call the function to check if the player is moving. And in our function, we're going to have it check. So if the player is moving, it's going to return true. And since it's going to return true if they're moving, this if statement is going to be true, which means it's going to go and check this if statement to check if the player is holding spacebar. And, you know, we're on the ground standing with the flag. But it's not necessarily good to have it running continuously like that and constantly getting our position when we don't want it to. So we're just going to add one more little check. So under values, we're just going to set a boolean can, or yeah, just can bhop. So yeah, I'll just actually skip that. So pretty much we're going to go ahead and write this function first. So what we want to do is get the velocity. So we're going to make our little, remember it's x, y, and z positions. So one way to get that is you can either make a float array that stores, well, just the size of 3, or you can simply make a structure that holds these for you. So the general name for that people use is vector, so we're going to follow along with that. So struct vector. Now we need our x, y, and z's, so float x, y, and z. Now we need to actually make something off of that. So let's see, we're going to call it darn voice is giving up. So we have our velocity here. That's what it's called. So we're just going to do vector player vel for velocity. Now we're going to read it. So mem class dot, am I not calling it mem class? Alright, this is internal. Duh. Alright, so we're going to do, yeah. So vector. Now we want to get the offset, so that would be, as we say here, local player plus the offset. So val dot local player plus offsets dot velocity. So we should be reading it now, and just to go off of it. So now we want to add them together, just like so. So remember, change them to an integer. So int vel for velocity equals player velocity dot x plus player velocity dot y plus player velocity dot z. So you can see how our structure here is working and storing the values. So, whoops. So if velocity does not equal 0, return true. If it does return something other than 0, return false. It's as simple as that. Oh, right, semicolon. Derp. Alright, so, yep, it's calling the function. So now, when we test it, oops, come on, hopefully it should go quite well. We'll just use guided hacking's injector. Go ahead and inject it. So now let's see if we can bhop. Alright, so we can bhop. Let's type. And I'm pressing spacebar, and you see it's not doing anything. But I'm holding spacebar while in game. And you can see everything is going along just fine. I can bhop just as normal. And if I tab out and I press spacebar, nothing's happening again. So a quick iteration. Well, we'll just do the stuff on the new stuff. So where are we starting? Right here. So all we did was make one little function to check if the player is moving. So if the player is moving, we're going to have it return true, and if they're not, we're going to have it return false. So if it returns true, we're going to check if the player is holding spacebar, and the flag is equal to us being on the ground. If that is the case, we simply set our force jump value to 6, which forces a jump. So inside a player is moving, we use our created vector here as that we use as a structure, call it player velocity. We read in the x, y, and z values into this vector called player velocity. Then we want to tally them up together. So if velocity for the x, y, and z axis is equal to 0, well, we want to add them up. So then if those x, y, and z values are equal to 0, well, if they do not equal 0, we want to return true, meaning the player is moving. So if you jump up, your z value is going to be increased, meaning it's going to return true because velocity no longer equals 0. Same thing if you're moving forwards, left, right, anywhere. So it's just, if you're moving period, it's going to return true. And if you're standing still, just like I am now, and I'm typing blah 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 blah, it's not going to do anything. But because this first jump is initiated as a normal jump, it counts as me moving, which is why I am currently bouncing. Well, bunny hopping. So, anyways, that's all, and hopefully that was kind of helpful.
Thank you so much for watching. As always, if you love guided hacking, please like and subscribe and share our videos with your friends. If you want to donate, guidedhacking.com/donate. You can use PayPal, cryptocurrency, or become a patron on Patreon. That's patreon.com/guidedhacking. Thanks again for watching, and stay tuned for more.